Hi dear students, in the last class we discussed about a remainder theorem. So in today's class we are going to study how to apply the remainder theorem. So let us start with exercise 2.3. So here goes the very first question of the exercise. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. First of all, we are going to find x plus 1 by x plus 1 means here there is a polynomial given. What is that polynomial? X cube plus 3x square plus 3x plus 1. We have to check the remainder which we obtain by dividing the given polynomial by x plus 1. Okay, so first of all, the given polynomial p of x, right? P of x is equal to x cube plus 3x square plus 3x plus 1. You got the p of x. Now inside this one, what you want to find? You want to find the remainder when this p of x is divided by x plus 1. How will you find? We can find by long division method, right? But actually if you are going with the long division method, it will take a lot of time and it will sometimes students may get worried when they are doing this one, because there are a lot of steps, and also if in between if you miss any one of the steps, then everything will go wrong. So there lies the importance of remainder theorem. In remainder theorem, if you are applying remainder theorem inside this one, very fast you can find the remainder. That's what its name is, remainder theorem. How to find the remainder without using actual division method. That's what we are going to discuss with. So here, what is the g of x given? P of x already I told you. Now the g of x is x plus 1. So I will tell you the trick how to understand this one. First of all, whatever g of x is given, here it is x plus 1. This x plus 1, you have to find the 0 of x plus 1. In the previous class, we have studied how to find the 0 of a number. How to find the 0 of this number? You have to equate this to 0. And then from that one, you have to find the value of x. So here it is x plus 1. So we will check it as x plus 1 is equal to 0. Therefore, x is equal to minus 1. That means p of minus 1 will be the remainder of this question. Means if you want to find the remainder, you have to find p of minus 1. So let us go for it. P of x is already given. What is p of x? X cube plus 3x square plus 3x plus 1. Now p of minus 1 is equal to, wherever you are seeing x, replace the x with minus 1. So minus 1 the whole cube, right? Because it is x cube. Minus 1 the whole cube plus 3 into instead of x square we will write minus 1 square. Minus 1 square plus 3 into again minus 1 then plus 1. Whenever you are substituting the value, it should be within brackets. Last class I remind you, right? So again, let me remind again, because it's so important. You have to put the substituted value within the brackets only. Now that's equal to, what about the cube of minus 1? It is minus 1 itself. So minus 1 plus 3 into, what about the square of minus 1? It is plus 1. So 3 into 1 plus 3 into, here it is minus 1 itself, right? 3 into minus 1 plus 1. That is equal to minus 1 plus 3 minus 3 minus 1. Here you can see minus 1 and plus 1, they will get cancelled. Minus 3 and plus 3, they also get cancelled. So the final answer will be 0. So you got it as 0. Let me just ask you one more thing. If the remainder is 0, what does it mean? It means that x plus 1 is a factor of the given polynomial x cube plus 3x square plus 3x plus 1. That's the meaning. Okay, it's not asked in this question, but I just shared with you because it's very important theorem. In the next topic, in tomorrow's class, when we are dealing with factor theorem, there we will have to understand this one to a wider extent. That's why I just remind you, whenever you are getting the remainder as 0, forget not that it will become the fact. That is the factor. Okay. Now one more question. Question number 2. The same p of x, that means x cube plus 3x square plus 3x plus 1. The same p of x we are using, and now you have to check whether x minus 1 by 2 is a factor or not. Okay, that's what we are going to check. Means from that one only we will get the remainder. Now x minus 1 by 2 is equal to 0. Therefore x is equal to 1 by 2, right? So p of 1 by 2 you have to check. Whatever value you are getting while checking p of 1 by 2, that will be the remainder. Okay, so p of 1 by 2 is equal to, first of all, it is x cube. So 1 by 2 the whole cube plus 3 into x square. Instead of x square, 1 by 2 the whole square plus 3x instead of x, 1 by 2. So 3 into 1 by 2 plus 1. That is equal to 1 by 2 the whole cube. What is 1 by 2 the whole cube? It is 1 cube by 2 cube. Means 1 by 8. Right? 2 cube means 2. It's not 2 into 3. It's 2 into 2 into 2. Okay. So 1 by 8 plus second term 3 into 1 by 2 the whole square. What is 1 by 2 the whole square? It is 1 by 4. So 3 into 1 by 4 means 3 by 4 plus next term 3 into 1 by 2. 3 into 1 is 3. So 3 by 2. Then plus 1. Now you got 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Taking the LCM, you will get it as 8. Now adding the numerators, it is here you can see on the numerator part 1 plus 6 plus 12 plus 8. Adding all together you will get 27 by 8. So 27 divided by 8, that will be the remainder when you divide x minus 1 by 2. Is that clear? So you got the remainder. Third question, one more question from that type. Here it is x itself. X. That means what is the remainder when you get by dividing the given polynomial by x. So as I told you earlier, whenever you are getting g of x, you have to equate it to 0. So here it is only x. So x is equal to 0. That means you have to find p of 0. You have to find p of 0. So p of x is equal to x cube plus 3x square plus 3x plus 1. So p of 0 is equal to, tell me, instead of x you will have to change it with the 0. Substitute the value of 0 for every x. 0 cube plus 3 into 0 square plus 3 into 0 plus 1. What is 0 cube? It is 0. 3 into 0 square, again 0. 3 into 0, again 0 plus 1. Adding all together you will get 1. So 1 is the remainder when you divide the given polynomial by x. The another questions you can do it by yourself. Try it by yourself because it's already given in the notes also. So you can do it by yourself and check the notes and make sure that what you have received is the correct solution for the given problem. Coming to the main question number 2. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. So here the polynomial is given. It is x cube minus ax square plus 6x minus a. And here the g of x is x minus a. You have to find the remainder. So x minus a is equal to 0. First of all, we will equate like that, right? X minus a is equal to 0. Therefore, x is equal to a. You got x as a. Now, you will have to find the p of a. And whatever the value of p of a is, that will be the remainder, which when divided by x minus a. So, whenever you are getting a polynomial and here it is p of x, we will name it as p of x. When it is divided by another polynomial, how to find the remainder by using remainder theorem? Equate the g of x to 0 and find the x from that one. And whatever value you are getting for x, place it inside the p, means p of that one you have to find. That will be the exact remainder. That's what we call remainder theorem. So here we are going to find p of a. Here the p of x is given. What is the p of x? It is x cube minus ax square plus 6x minus a. So now p of a is equal to, wherever you are finding x, instead of x you have to substitute it with the a. So what will become? P of a is equal to a cube minus a into a square, because a is already there and instead of x you have to substitute the value of a. So a into a square plus 6a. Why 6a? Because it was 6x. 6a minus a. Here a cube minus a into a square is a cube itself. So a cube minus a cube plus 6a minus a. A cube minus a cube is 0. Then 6a minus a. 6a minus a means 6a minus 1a. It is 5a. It is 5a. So you got it as 5a. Main question number 3. Check whether 7 plus 3x is a factor of 3x cube plus 7x. So there is p of x given, 3x cube plus 7x, and g of x is 7 plus 3x. You got g of x 7 plus 3x. So let us equate it to 0. 7 plus 3x is equal to 0. 7 plus 3x is equal to 0. Therefore 3x is equal to minus 7. X is equal to minus 7 by 3. So you have to find p of minus 7 by 3. And if this p of minus 7 by 3 is equal to 0, then we will say yes, it is a factor. And if it is a non-zero, if it is not equal to 0, if it is a non-zero number, then we will say it is not a factor. Let us go for it. P of minus 7 by 3 is equal to, Here it is 3x cube is the first number. So 3 into minus 7 by 3 the whole cube plus 7x is the next number. So 7 into instead of x minus 7 by 3 again. So 3 into what is minus 7 by 3 the whole cube. 7 into 7 into 7 on the numerator, 3 into 3 into 3 on the denominator. So 7 cube, it is 343 divided by 3 into 3 into 3, it is 27. First time is over. Then plus 7 into minus 7 by 3, right? That's equal to, again, this 3 and 27 will get cancelled each other. 9 will be there on the denominator. On the top, it is minus 343 divided by 9. Again, minus, because 7 sevens are 49. 49 divided by 3. Now taking the LCMs, finally you will get minus 343 minus 147 divided by 9. Next step, that's equal to minus 490 divided by 9. See, minus 490 divided by 9, will it become 0? No. If it should become 0, the numerator part should become 0. But here, the numerator is not 0. If the numerator is not 0, that means the value is not equal to 0. So there is no need to find the answer for this one. Simply here itself you can stop and you can say this is not equal to 0. Therefore, what we can conclude from this one, 7 plus 3x is not a factor of 7 plus 3x is not a factor of the given polynomial 3x cube plus 7x. This is how we have to check. So I hope you understood the class. This is the application of a remainder theorem. See how easy it was, right? In the previous video we were studying about long division method. It was long and lengthy. If a third degree polynomial is given and if you have to divide it by second degree polynomial, then it will go much more lengthy, right? So here that is the use of remainder theorem. Very fast we can find the remainder. Now we are going to the next topic after this class. Tomorrow we will study the new topic, that is what we call the factor theorem and the application of factor theorem. Now we studied about remainder theorem, and that is the factor theorem is the next higher degree of this remainder theorem. So we will meet tomorrow in the new section. Till then, take care and goodbye.